Here we're going to talk about categorical variables and how to work with them in R. Now, I highly recommend referring to the Introduction to Statistical Programming with R draft that I've written, and specifically going down and looking at sections 613 and 614, which has a bit more detail and some more examples than what I'm going to be going over here. So a categorical variable is something like state of origin, favorite color, something whose possible values are typically text. So how does R store them and how do we work with them? It turns out that R has a special treatment when it comes to bona fide categorical variables. Now, the vector of values that I'm going to work with here is as follows. We have a bunch of A's, B's, a blank actually, kind of a pair of double quotes with nothing in the middle, a period, a C, and a D. Now, if I just print that to the screen, what we'll see is that, okay, here are all the values. And if I want to treat that as a categorical variable, then I need to make sure to set it up properly. So if I did something like left arrow this vector into a quantity called x, and then ran the class function on it, R would report back that it is a character vector. And so that's actually somewhat limiting. If I wanted to run a summary on the elements of x, I wouldn't get anything very informative. And that's because R is not actually treating it as a categorical variable. It's literally just treating it as a bag of words. So what we need to do in order to treat a vector of values as a categorical variable is to use the factor function. So the way to actually make an object a categorical variable is to give it a vector of values and wrap that inside the factor function. Once I do this, now I can look at a summary of these values, and you'll notice that it prints out a frequency table. Now this blank is actually represented by this empty space right here. We have two blanks in that vector. We see that we have a list of numbers, basically the frequencies, that each one of the levels appear. Now, levels is a key word associated with categorical variable. A level is just a possible value that that categorical variable can take. And it turns out that the levels vector of a categorical variable is something that R treats, very special. So let's talk more about the levels vector. It turns out that I can run the command levelsx on my categorical variable, and that'll print out a text vector that contains the values of the levels, the possible values that are valid for this categorical variable. Now this is important because R is going to keep track of the values inside of the categorical variable and its possible levels separately. And this is actually a good idea because it might be the case in the data that you've collected, you just don't have one of the many possible values. If we have a data set keeping track of state of origin, maybe all of the states we have in the data are just in the southeast. We might be missing Washington, we might be missing New York, but those would be possibilities that we want to know that are valid. We want to have R respect that. So levelsx is going to let us keep track separately what the possible values are, even if we don't see those values in the data. And it turns out that that actually comes with a significant amount of baggage. To work with a categorical variable effectively, we're going to have to worry about how we manipulate the levels vector of the categorical variable. All right, so we've talked about how to create a categorical variable, basically use factor on the vector of values that we want treated as the categorical variable. And in fact, we can do this with any really existing vector. So if I had a vector called just numbers, and let's say I had a bunch of ones, a bunch of twos, maybe a decimal place or two, something like this. Right now, that's just a numeric vector here, but I can convert that into a categorical variable if I wanted to. Maybe these represent version numbers of software, and I don't really want to be treating them as numbers. I could say, all right, numbers as factor, just create that variable called that. We could just put in just numbers as the argument of factor, and now all of a sudden I would actually have this vector being treated as a categorical variable. So here's my frequency table, the list of possible levels actually up on top, and the number of times I see each level represented down here. So I can convert a vector of numerics to a factor just by using the factor function, and the same thing with converting text into an actual factor, which was the example we had up here. All right, now it may be the case that you don't want R to keep track of levels that aren't represented in the data. So if our example has state of origin, we have 50 possible levels, maybe we're really only dealing with data from the southeast, and so maybe we don't need to have R keep track that Washington, California, Nevada is a possibility. So there's a command that removes unused levels from a categorical variable. This actually works for a data frame as well, called drop levels. So let me go back to this x vector, which is now a categorical variable because I've used the command factor. I'll print out its values here. And what would happen if I, say, wanted to remove this c? Well, I know how to remove elements from a vector. I can ask, all right, which element of x is equal to c. Turns out that's the 8th element. Maybe I could just redefine x to be everything but that element. So if I take out the 8th element, which is what that which command evaluates to, what I'll notice is that, all right, I don't see c anymore in the list of values, but I still do see c in the levels vector. And it might be the case that I just want to have R forget about that. I might not want to keep around that level. And there's a few good reasons for that. If you're making a bar chart, R is going to create a bar for every level, even if there isn't any of that level in the data. Just so that you see what I mean, we could ask for bar plot x, really bar plot table x, and we'll see that C, even since it's not in the data, has a space in the bar plot, but no height to it because its frequency is 0. And we might not want that. If we have a categorical variable with 50 different levels and only 3 of them appear in the data, this bar plot's going to look like a mess. So how do we get rid of levels that don't actually appear in the list of value? The drop levels command. So what we might do is we might use the drop levels command to redefine what x is. If we do this, we'll see that C no longer appears as a valid level here. And so now if I were to run that bar plot command, we'll notice that C is missing. All right, so the key thing to remember with categorical variables is that R is going to keep track of what's inside the categorical variable, the values of it, and the levels vector separately. And so it turns out that makes actually manipulating categorical variables in R a bit tricky. So what if we wanted to add in a new level to a categorical variable? Well, it turns out it's not just as easy as, say, appending a new element to a vector. So let me just illustrate this by having the vector 1, 5, 7, a numeric vector. Here are its contents. We know that, okay, if I want to append, say, the number 9 to this list of numbers, well, what I could do is I could just say, all right, let's make a vector that contains the elements of x first, and maybe the number 9 that follows. If I do this, 9 appears at the end of this vector. Now, what's a little bit odd is that that's not going to work if we're dealing with a categorical variable. So once again, I'll create this factor right here. Here's our categorical variable. Look what happens when I take the current values of x and say I add in the new additional level. I'm going to call it new level. So new level is a value that's not inside the levels vector of this categorical variable. So if I try to append this to the end, make it the last value of x, I'll see something rather odd. So I do see new level as the very last element of this result here, but all of the values inside have changed. In fact, they've changed from A's, B's, dots, and blanks to numbers. These numbers actually represent the position of that level in an alphabetical list of levels. So actually, the blank gets the number 1, the period gets the number 2, A gets the number 3, etc. But that's not what I want. And in fact, you'll notice that by trying to create a vector this way, I have actually prevented it from being a categorical variable. This is just a text vector. So it's not as simple as just appending a vector with new values that the categorical variable's never seen before. I actually need to be a little bit careful about this. If I do want to add a new level, I have to work with the levels vector specifically. What do I mean by that? Well, right now the levels vector is blank.abcd. If I want to add a new level called new level, this is what I have to do. I have to say that I want the levels vector to be, all right, the values that it currently is. I'm going to make a vector containing the values of the levels vector as it is right now. And I'm going to append in the name of that new level. And I could put in more than this if I wanted to. I could say new level 2, new level 3. I could put as many new levels as I wanted here. But the key thing is I need to take the values that the levels vector currently contains and make a vector with that and all of the new levels that I want it to have. So once I do this, you'll notice that if I print out the levels vector of this categorical variable, we have these 3 new values, meaning that these are 3 new possibilities that values inside that categorical variable can take. If I print out the contents of x, I see that, yep, the levels vector has been updated. I don't have any of these 3 new levels, but now I can go ahead and say add in new elements to that categorical variable. So right now, I have 13 elements in x. So I could say, well, let's let the 14th element be new level. If I do this, then I'll see that indeed new level appears as the very last element of my categorical variable. If I tried to just say, okay, well, let's have that next element be a super brand new level, it's actually going to give me a warning message. And that's because super brand new level isn't part of the levels vector, so I'm not actually allowed to add that to the categorical variable. If I print this out, I see a big old NA, meaning that, hey, this is missing. Didn't know what that was really referring to. So I'm going to get rid of that last element. Oops, that's not the way to do it. Get rid of that 15th element, and now it's back to where I am here. All right, so that's how we add a new level. We actually have to manipulate the levels vector itself. I have to take the existing values of the levels vector and create a new vector with the current values and whatever the new values for the levels I want to be. Create a vector out of that, left arrow that in to the levels vector. So we've talked about removing a level. That's just with the drop levels command. And you'll notice right now that x has more levels than unique values that appear in here. I don't have new level 2. I don't have new level 3. So let's do that drop levels command to get rid of it. So now only the levels that actually exist in the vector itself appear. All right, it may be the case that you want to rename levels. It's kind of inconvenient that I have a blank inside my values of x. That makes a few things very difficult to see. So when I make a summary of x, what we see is that, all right, the blank is represented by literally a blank. There's nothing on top of this 2 here, and sometimes that can give some rather confusing output. We don't really know what that's referring to. So table x, summary x, or even making the bar plot gets to be a bit confusing because this blank appears, but we don't really know what that corresponds to. So we might actually want to rename maybe this blank to something more informative. We could actually call it blank, or we could call it missing. All right, so how do we rename levels? Well, there's a few ways to go about doing this. I'm going to tell you the safe way of doing it. It's kind of verbose, the command's long, but by doing it the safe way, you're guaranteed not to mess up your data. I'm not even going to mention what the dangerous way is. All right, so how do we rename a level? Let's look at that levels vector again. Let's say I want to rename that blank, and I'm going to rename that dot to be missing. What I'm going to do is I'm going to redefine specific elements of my levels vector to be what I want them to be. In this case, I want the first and the second elements to be called missing. And so I would need to be clever about what I'm putting inside the square bracket so that I do this correctly and the safe way. So levels x is this string of text right now. The ones that I want to change are basically the levels that match up with my %n shortcut and the which command. So which levels x are inside the vector blank and dot. Let's break this down. So here we have levels x, which levels x are either one of these two symbols. Well, the first and second elements are. If I printed out that whole command, I'd see that, yep, those are those two levels. I can rename just those two levels to missing as follows. So we see that we've gotten rid of those two levels, replaced those two just by missing, and this is what you're going to want to do. So to rename levels the safe way, you're going to set up a command that looks like this. You're going to start out by saying, all right, let's take those levels of x, and then we'll put some square brackets right after that, because we want to refer to which levels we want to be renaming. Now we'll do this the safe way by using the which command. We'll say, all right, inside the square brackets, we'll have the which levels x, and then we can put the %in shortcut and give it a vector of levels that we want to rename. Now, very often, you just go on and rename one level, in which case we can just have a vector of length 1. Here, I wanted to rename two levels at the same time, kind of being fancy about it. But here's the basic syntax. So take your levels vector, put the square brackets, and inside those square brackets say which levels %in, and then give it a vector of level names that you want to be renaming. Make sure all those parentheses square brackets are closed out, and then left arrow that to the name you want to give it. And now we've successfully renamed those levels. If we look, we see that, okay, this is much nicer. If I take a summary, I don't have any of these values that no longer have a label above it. And we're going to use the same sort of technique to combine levels. Well, here we actually combined blank and dot into a level called missing. And this is a pretty common task. Very often in data we find very rare levels, so we might want to combine all the levels that appear, say 3 or fewer times, into a new level called rare. So how do we combine levels? Well, there's a safe way and a dangerous way. The dangerous way is mentioned in that Intro Our Programming PDF, but I'm only going to talk about the safe way here. It's a verbose command, but it's always going to work and it's not going to mess up your data. It's basically going to do the exact same way, the exact same approach that we did when renaming the levels. All right, so right now, I'm going to take this once again, redefine x to be this guy. Let's say that I just want to have two levels that appear in my categorical variable. I basically want to have missing and I want to have present. So maybe we're dealing with a donor database where we either do or don't have information about a particular field. Maybe a lot of the values are missing, like blanks and the dots. Maybe when we do have values, well, it's broken down in a little bit more detail. Either they have possibility A, B, C, or D. But we're just going to take the simple approach and say, well, do we either have information or do we not have information for this individual? So for this example, I want to combine A, B, C, and D into the level present and blank and dot into missing. Now the nice thing is I've actually done this combination into missing. So I'm going to do this but in a slightly different way. So same sort of trick here. We have to manipulate the levels vector directly. Right now this is what the levels vector looks like. We want to replace this blank with missing. We want to replace this dot with missing. We want to place the A with present, B with present, etc. So what we'll do is we'll put square brackets after the levels vector and say which level we want to change. So which levels x, and I'll use the %in shortcut. And in this case, I'm going to do it all or one by one here. So we're just going to take the blank vector right now. So making a vector with one element, a blank, double quotes, nothing in the middle. So where is that in the levels vector? Well, that's the first position. I'm going to left arrow that to be missing. So when I do this, I'll notice that, okay, it's updated. I can do the same thing for the dot. And then it's going to be the same sort of approach here. If I want to combine A, B, C, and D, well, I just put in A, B, C, and D all the levels that I want to combine in a vector to the right-hand side of the percentage in, and left arrow that to the new name. Kind of like what I did up here with missing. There's no reason for me to do this line by line here, just to illustrate that if you only wanted to, say, rename one level, this is how you do it. But we'll notice that, let me start from the top. Bam, bam, bam. Levels X is now missing in present. Getting a table of those. Getting a bar plot. There we go. So combining levels, easy once you get the hang of it. The syntax of this command looks really long, but once you get used to typing it out, it's fairly straightforward. To combine levels, you type out the levels vector, put square brackets, and then use the which levels percentage in, and then give it a vector of level names that you want to be combining. Now, occasionally, you might have a categorical variable with a tremendous number of levels. And basically what you want to do is combine everything but a small number of those levels into one particular level. So like in this case, we combine 4 levels to be present, but what if I wanted to combine, say, 100 different levels to have the same name? It'd be rather tedious to go through and actually type out a vector of every single one of those 100 names that I wanted to change. So there's a shortcut for combining everything but a certain set of elements that's worth talking about. Now it's going to use the same syntax that we've been using to combine or rename levels. And it's going to look rather funky because I'm going to put in a single exclamation point to help us out here. All right, so the way that I'm going to do this is I'm going to define my x vector, this categorical variable, to be, let's see, the empty cars data frame. This is something that R knows about. The MPG column of that. Now, MPG, miles per gallon, is a numerical vector here. I'm going to treat this as a factor. Let's imagine I want to treat it as levels of a categorical variable. Do I have any duplicates here? I do. All right, so let's imagine that I wanted to combine everything but 10.4 and 13.5 into a level called large. Let me actually type that out. Combine everything but the levels 10.4 and 13.3 into a level called large. If I wanted to use this syntax up here, that would require me going through and typing out, all right, 14.3, 14.7, 15, 15.2, and no one's got time for that. So what I'm going to do, because I want to combine everything but just these two elements, these two names of possible levels, I'm going to use this to my advantage. So what I'm going to do is I'm going to type in, or just copy and paste in this case, the two levels that I don't want to change. 2 is not so bad to actually type out. Right now, this command as is just going to print out 10.4 and 13.3. If I take the levels vector, square bracket, and say which levels x in 10.4 or 13.3, I'm going to get out those two levels. But I want everything but that. So here is where to put that strategic exclamation point. Right before the levels command inside the which, that's where I'm going to put the exclamation point. And then what I'm going to do is I'm going to put a left parenthesis right before that, right before the levels to separate the two. And I'm going to put in one more parenthesis to close off that parenthesis that I just created. So all I need to do is make sure that there's a whole bunch of parentheses right here. Just add in an additional one inside that right square bracket here. So the way that this command is read is basically as follows. Look inside the levels vector and find which levels are not these two values. If I just run this part of the command as is, well, here are all the levels that are not 10.4 or 13.3. And I can combine those all in one fell swoop to just be large. And there we go. That's a quick way of doing everything but the safe way. At least there's a dangerous way of doing it, but we won't talk about that here. And so there you go. That should help you out with working with categorical variables in R. Key thing is R keeps track separately the values of a categorical variable and a list of the possible values, the levels of that categorical variable. And to become proficient at manipulating categorical data in R, you just need to become proficient with working with that levels vector, because that's where really all the heavy lifting comes in. And one last thing, we should talk a little bit more about conversion from factors into text, conversion from factors into numbers, etc. So in this example up here, I'd created a vector called just numbers, which is a vector of just numeric data, and I made it into a factor by running the factor command on it. So we treated each of the possible values that I saw in that vector as a level of a categorical variable. Now, what if I wanted to recover those original numeric values? It turns out that I have to be a bit careful on how I do that. So one thing that you might know about is the asNumeric command. Basically, the asNumeric command is going to try to take what other object is passed to it as the argument and convert that into a vector of numbers. And a lot of times this works fine, but it doesn't work for factors. Why is that? Well, let's look what happens. Right now, we have a vector just numbers here. Here are the values. What's going to happen if I run as.numeric on just numbers? Well, actually, numbers is factor. Let's do it the right way. So I start out with my categorical variable, 1s, 2s, 3.4, 3.3, 3.4. I run asNumeric on it, and, well, it looks like some of these numbers are right. We start out with 1s and 2s, but now all of a sudden I have a 4, then a 3, and then a 5. So this 3.4 became a 4, this 3.3 became a 3, and this 4.4 became a 5. What's going on? Well, when R runs asNumeric on a categorical variable, it's going to replace the values with numbers, but the numbers that it's going to replace with are just the position inside the alphabetical list of levels. So what do I mean by that? If I look at the levels vector of this numbers as factor, 1 is the first level alphabetically, 2 is the second level, 3.3 is the third level, etc. So when asNumeric gets run, okay, this 1 will remain a 1 because it happens to be the first level alphabetically. The 2 is going to remain a 2 because that's the second level alphabetically. But this 3.4, which is the fourth level alphabetically, is going to get converted into a 4. So that's why this 3.4 here becomes the 4. 3.3, the third alphabetical level, becomes a 3. And this 4.4, the last fifth level alphabetically, becomes a 5. So how do we prevent that from happening? Well, what we need to do is we actually need to convert it to text first. Because it turns out that if I run asNumeric on a vector that contains numbers in double quotes, basically represented as text here, R knows what to do with that. R converts text to numbers appropriately. It doesn't convert factors to text appropriately. So what we're going to do now is just to start out with our just numbers, make it a factor. It's a factor right here. If I want to get those numbers back, I can do that. I just need to convert that to text first by running as.character on my categorical variable. So asNumeric as character is going to recover those original numbers.